In this presentation, we're going to be looking at migrating your project to OpenRoads Designer. There's a couple of preliminary issues that we want to deal with, and the first one is working units. If your project working units are different from those in your ORD workspace, you should be fine. However, it's recommended that you use seed files consistent with your existing project files. This way you won't be mixing DGN working units within the project files themselves. A second issue that you need to be aware of is how features are going to be handled when migrating a V8i project forward. All feature names will be created from the source V8i data. Now, this can create a challenge if you've changed your feature names from V8i to ORD, as you will have to deal with what we call unsupported features. In other words, these are features that existed in your V8i project or workspace, but no longer exist in the ORD workspace because they've been renamed. Now, if you've only changed a few features, the manual work necessary to update those features is probably going to be minimal. However, if you've changed a lot of feature names, then the work, of course, could be significant. In this scenario, one option to consider would be to create a custom workspace that supports the older feature names. So in this presentation, we're going to be looking specifically at a GEOPAK project using non-OpenRoads technology. So for example, this could be an SS2 project, SS3, SS4, or even an SS10 project, but it's using all legacy GEOPAK applications and no OpenRoads technology. Now, the first thing you want to do is run reports in your current version. These can be geometry reports, super reports, corridor, and drainage reports. We'll use these at the end of our migration in order to validate that all our data has come forward properly. Next, we'll want to import our terrain.
To import a terrain, we'll start from a 3D seed file. We'll hit Create from File, choose our terrain. In this case, it's an InRes DTM, but we have options for a GEOPAK tin as well. We'll click Done, and we'll plug in all the information we know. If we have the source file units, we can plug it in. If not, we don't need to. We can leave it as unknown. I do want to make sure I choose the feature definition. I want to see contours and triangles, so I'm going to choose the contour and triangles feature definition. And for this example, I want to choose import terrain only. And here we have our triangulated DTM or tin in a terrain model in the DGN. Next, we're going to create a separate file for our terrain features. We're going to hit File New, label it Terrain Features, and we're going to make sure we choose a 3D seed file. We're going to follow the same steps that we did before. We're going to create from file, choose our DTM. If we wanted to change a feature definition, we can, but we don't need to. In this case here, we're going to import features only, and we're going to make sure we check that box Name All Features. As we can see, our 3D linear elements have been imported from our features, and they're named appropriately. These should be the same names that were stored in the DTM. The next step is to change all of the features that we want to be using to the appropriate feature definitions. In this case here, we're going to be changing a ditch feature definition, and we'll turn off everything else so that we can see our ditches clearly and we can recreate our point controls later. Instead of clicking every single feature and changing the feature definition through the Properties dialog box, we do have the ability to open up Explorer, find our 3D linear feature, and change all of them all at once. Before we leave, we'll make sure we'll turn off all the levels that we don't need, and we'll save the file.
Our next step would be to import our geometry.
In this video, we're going to import a GPK. We're going to start with a 2D seed and create a new file called Geometry GPK. To import the GPK, we're going to go to our Geometry tab, General Tools, Import, navigate to our GPK. And as you can see here, we have multiple file types, including an ALG or XML. We'll drill down to the alignments that we want to import. We may not want to import all of them, but as you can see, if I select the parent, all of its children will get selected. In GEOPAK, vertical alignments and horizontal alignments are independent. Verticals are not children of horizontals, so we'll need to make sure we tie the appropriate child profile to the horizontal alignment. In OpenRoads Designer, there is no need to import the existing ground profile. This will be taken care of in the software, as we'll see later. If a profile or vertical alignment includes the name of the horizontal alignment, it will automatically be selected. So if the horizontal alignment named ramp 1 has multiple profiles, the profiles that include ramp 1 in those names will be selected. Once we hit import, the next step that we're going to have to do is set the feature definition of every alignment. The best way to do that is by going to the General Tools, Setting Standards, Set Feature Definition, choosing our alignment feature type, selecting our feature definition, and selecting our alignments. This will set the feature definition of the horizontal and all of its profiles. This is required for horizontal and vertical annotation to work appropriately. What we could also do is annotate our geometry in our plan view through the element annotation and selecting each alignment, or through the model annotation, and it will annotate everything set to annotate in this model. We can also change the drawing scale to increase or decrease the size of the text. To check if the vertical alignment has the appropriate feature definition, we can open up a profile view, select a profile, and look at the properties. Now, using the Set Feature Definition tool, all of the profiles will have this feature definition. I may want to select all the other profiles and change a feature definition to something that does not annotate. As a good practice, I'll also want to make sure I set my active profile, which is the main profile of my horizontal alignment that I'll be using for all my corridors, as the active profile. And I'll also want to attach our existing terrain model and set that terrain model as active so I could see it in all of my profiles.
Before moving on, we need to consider the use of the ITL Re-Mapper utility. This utility can be found under the Bentley Communities under Migration Utilities, and you'll see here the template library ITL Re-Mapper. This utility is used to convert older feature names in an ITL to the new feature names contained in the ORD workspace.
In this video, we're going to map our feature definitions from the old template library to the new template library in OpenRoads Designer. We're going to use the Migration Utilities ITL Feature Mapping tool, and we're going to open up these two CSVs, the Point Feature Mapping and the Component Feature Mapping. In column A, we have the old feature definitions. In column B, we have the OpenRoads Designer feature definitions in both the points and the components. If they happen to match, they will map directly from the old way to the new way. If they don't, we want to make sure we fulfill the appropriate names and save them and get out. Then we'll open up our ITL Feature Mapper executable. It's going to ask us for the component feature mapping file, so we'll select our CSV. Then we'll then select our point feature mapping file. And then lastly, we'll select our template library. Once we hit process, a log will be created to identify all of the points and components that did not map appropriately. Let's go ahead and take a look at that log and see which ones did not map appropriately. Here we can see we have PR ditch, V-shaped, profile V left and right. Let's take a look at our feature mapping CSV to compare. And here we see that they should have been mapped, but because of the quotations in the XML did not map appropriately. So what we can do is replace all the quotes in this file with this string, end quote, semicolon, and that's how we'll find it in the XML, in the template library. Now we'll open up our ITL with Notepad++ or Notepad or any type of text editing tool, and we'll perform an edit replace with these 3-point feature definitions. We'll save it, we'll close it and get out. Open up our template. First, let's take a look at our original components. We can see that a lot of the feature definitions are white. If they don't have matching names, you'll get this error message that says it's not found in the current design file or in the dgnlib, and they don't have a feature definition assigned. If we didn't want to use the feature mapper tool, we can select each template one by one and apply feature definitions to points in bulk. This also works for components as well. Now let's open up our remapped template library and take a look at the difference. As we can see that all of the feature definitions have mapped appropriately. Depending on the version that we've upgraded our template library from, we may need to add the Superelevation flag. We can do this through all of our templates one by one by clicking on each individual point and checking the Superelevation flag. We'll have to do this for every template that has Superelevation. Or we can go through each template and apply them in bulk using the Apply Superelevation to Points, selecting all of our points, checkboxing the Superelevation flag, and hitting Apply. Once we've finished checking everything over, we'll save the template library and close out. And we'll want to rename our old template library to a back file and rename the remapped to our original file name.
When importing Superelevation from your V8i project, you have two options. The first option is to use a CSV file.
We have the ability to import Superelevation in two different ways, one from a CSV and one directly from the IRD. In this video, we will cover how to import Superelevation from a CSV. We'll begin by creating a new file from a 2D seed. We will now reference in our geometry file that we will base our CSV import from. Before we begin our import process from a CSV, we're going to need to create the sections and the lanes. To avoid multiple Superelevation sections, we're going to choose a very large tangent length. We'll also choose a manual lane creation method. We're going to lock to start, lock to end, and then we're going to start creating our lanes. So first we'll build the right side, inside lane, and then we're going to build the right shoulder. Since we're importing, it really doesn't matter what the width is or what the normal cross slope is. Now that we've had 4 lanes created, we don't need to calculate the Superelevation from the wizard. We're going to begin the import process from a CSV. Calculate, import Superelevation. we're going to identify the CSV that we're going to import from. Now let's take a quick look at what the CSV looks like. Here we have two spreadsheets. The spreadsheet on the left is the report exported from the previous version. The spreadsheet on the right is a CSV format that we want to provide to OpenRoads Designer. So we can do this a number of ways. We can hand type some of these in. We can create a formula to push all of these into the appropriate format. The appropriate format looks like this, which can be found on Communities or OpenRoads Help. We want to save our CSV. This is the CSV that we're going to open. Here we're going to assign the lanes to the appropriate Superelevation lane in our CSV. So we want to make sure LT2 corresponds to our shoulders, LT to our edge of pavement from our left side, right edge of pavement, and right 2 for our right shoulder. Once we hit OK, we can see that our superelevation has been imported, and now we can open up our corridors and apply our superelevation to our corridors.
The next option we have with importing superelevation, as mentioned previously, is through the use of the IRD.
We have the ability to import superelevation in two different ways, one from a CSV and one directly from the IRD. In this video, we'll cover how to import superelevation from an IRD. We'll start by creating a new file from a 2D seed to import our superelevation. Then we'll reference our geometry file in. Next, we'll import the IRD. In previous versions, the IRD also contained the superelevation. We'll bring in the IRD, remove most of the corridor information, and we'll modify the superelevation. You may get this dialog box. We're just going to hit continue, and we'll worry about that when we have to import the corridor in another file. As with anything that we import, we want to select it and change a feature definition. Now we'll go to our corridor objects and select our corridor, and we'll start to remove our template drops and all of the other information that is no longer needed. The reason why we're keeping the corridor is because the superelevation is tied to this corridor. In OpenRoads Designer, superelevation can be assigned to a corridor or an alignment. As this came from an IRD, the superelevation is tied to the corridor. Then we'll go into our corridor and rename it from the original corridor name and suffix it with super, so that when we import this corridor in a separate file, there won't be duplicate corridor names. One of the ways that we can verify that our superelevation imported correctly is by running a superelevation report. We can also select the superelevation to CSV report, and we can export this to an Excel file that we can import onto an alignment instead of a corridor in the event that any major horizontal alignment change occurs. Once we verify that all of our superelevation imported correctly, we can then continue the process to import a corridor and tie this superelevation to that corridor.
Our next step would be to import our corridor.
Once we have imported our superelevation, we're going to create a new file to import our corridors. We're going to make sure we choose a 2D seed. We're going to reference all of our needed references. This will include our geometry, our superelevation that we just created, our terrain models. A good practice is to make sure that our existing terrain model is set to active. I'm going to turn a lot of these references off so that we can see things a little bit more clearer. I'll leave our superelevation and our geometry on. Next, we'll import our IRD from the Corridor tab, Create, Import from IRD. We'll navigate to our IRD, and we'll choose our proposed corridor to import. You may get this dialog box for missing corridor dependencies. These are important. We want to save these. We're going to have to recreate these point controls or have to redesign them from scratch. We're going to save our reports, save it on our desktop, and we'll refer back to them later. Once our corridor has been imported, we want to make sure we have our appropriate mapped template library open, and then we're going to sync all of our templates. And we have the option to choose a template drop or the whole corridor. Once the template drops are synced, we should see the feature definitions of the different colors. As with anything that we import, we also want to make sure that we change the appropriate feature definition to the new feature definition. So if we go to corridors, you'll notice that our corridor is not featurized. If we have our properties dialog box, we can go in and select our corridor and change our feature definition. When we import the IRD, it also brings in the superelevation into this file. Since we have our superelevation in another file, we're going to want to remove these point controls and delete the superelevation out of this file and recreate the point controls or assign the superelevation from our reference to this corridor. We can go to our superelevation in our Explorer, right-click, and delete. Once we delete our superelevation, you'll notice that our point controls related to superelevation are no longer there. We can now assign our superelevation from our separate DGN to our corridor. We're going to go to Calculate, Assign to Corridor, select our superelevation section, locate our corridor, and here we're going to make sure we assign our superelevation lane to the appropriate point and the pivot point. Once it all looks good, we'll go ahead and click OK. Now that we've had our point controls created for our superelevation, we want to verify them by looking at the dynamic cross-section view. We'll zoom in to our location, use a combination of Control or Shift, scroll up and down to change our exaggeration. We can verify our point controls through our corridor objects. And the last step is to re-add all of the missing dependency point controls. We can split our screen to have the dependencies on one side of the screen and our corridor and cross-section in the other. If we take a look at our missing dependencies, some of these points are point controls that may have been pointing to a DTM feature that is no longer supported. All of the features that used to be in a DTM are now imported as linear geometry. We'll turn on our terrain features file that we've created in a previous video. Here we have our ditches assigned to the appropriate feature definition. We have all of our information we need to recreate the point controls. We have the point we want to tie to, we have our start and stop stations, horizontal, vertical offsets, and the feature name. Once we've recreated all the point controls that didn't come in through the IRD, we can reference in our 3D DGN of any component displays from any of the previous versions of the corridors into our 3D version here and look at everything through cross-sections. So here I'm opening up the default 3D view. I'm going to attach our, in this case, SS2 components. And now I can compare in the dynamic cross-section view. The last thing I may want to compare is the design input reports from the previous versions to the design input reports from OpenRoads Designer.
Now at this point, you may or may not need to regenerate your sheets. This can of course depend on various factors such as where you are in your project and of course how much has changed since you've migrated your project in. If you do need to regenerate your sheets, there are numerous resources available to assist you in sheet production. The final piece of information that we'll want to migrate forward is our drainage. To do this, we have two options. The first option will be without using an OpenFlows product.
This is the GEOPAK drainage data that I want to import into a Connect Edition civil product. I'm running Power GEOPAK in this case, could equally be GEOPAK Suite. Now I'm running Select Series 10, so I see a subsurface utility menu, but in this workflow, we're going to look at how to transfer this data in a Select Series 2 version of GEOPAK. So in Select Series 2, the subsurface utility menu will not be available, so we need a different workflow. So I'm going to go into GEOPAK Drainage. I'm going to select the drainage project to load it. And then I'm going to go to Reports and Builder. I'm going to use the Report Builder to export GEOPAK drainage data to CSV files. And then in the Connect Edition civil product, I'm going to read those spreadsheets to create the drainage data. So the first thing I'm going to do is select a report file for areas. Now I've chosen the data that I want to include by selecting the items in the list of available data, clicking include to add them to the report data. I've typed an extension of CSV, I've set the number of decimal places and the delimiter, and I've checked on include field names. So you can see the data that I'm going to include in this spreadsheet. I can click Generate to create the CSV file. The next data that I'm going to export is the nodes, so I'll select that settings file. And again, you can see the data that I've selected on the right-hand side. The data that I've selected includes the location, X and Y coordinates, the elevation, the minimum invert elevation, the rotation, and then the ID, description, type, and a few other fields. Now, you cannot select too much information because when we get into the Connect Edition product, we can choose what information we want to read, but you can select too little. So we'll generate that report. Then we want to generate a report of the links. So again, I've set up my settings here. So the minimum information that we're going to need for the links is the upstream and downstream node. We want the upstream and downstream inverts. We want the rise and the span. We also want the ID, and then I've added a few other pieces of information, the shape, the material, the library item. So we'll generate that report. Again, I could add more information if I wanted to, such as the Manning's Inn, for example. And I can't have too much information because I can choose later what information I'm going to read into the Connect Edition product. Finally, it's not a requirement, but I could also, if I wanted, create a spreadsheet using information for inlets specifically. Now, I'm not going to do this in this demonstration, but note that you can create your spreadsheet to include properties such as the hydraulic characteristics of the inlets, the curb length, curb depression, slot length, grate length, and so on. So having generated the reports that I'm going to use, I can close the report builder and exit GEOPAK drainage. The next step is to open the CSV files that we generated in the report builder and save them as Excel spreadsheets. Now, in this spreadsheet, I've combined two of the CSV files for areas and for nodes. And we can see the data in the spreadsheet here. On the areas spreadsheet, I've supplemented the data that was provided by the report builder with some extra data that I've put in yellow here. Now, the GEOPAK report builder does not include any kind of coordinate data for catchment areas, but because the names of the areas have to match the names of the nodes that they discharge to, we can use the data from the Nodes tab to get the coordinates to use for the areas. So I've copied and pasted these two columns of data from the Nodes tab into the Areas tab, using just the nodes that have corresponding areas. I've also added in the node ID data from the Nodes tab there. And then finally, I've added one more column manually, as you see here. And we need to tell the Connect Edition product this information in a moment. I've also got a separate spreadsheet for the information that we created using the links in the report builder. So again, you see the information here. Let's just scroll back to the left and to the right. And again, I've manually added two more columns of data, as you can see here. And again, we will need to use these in a moment. The next step is to import the Excel data into the Connect Edition product. I'm using OpenRoads Designer Connect Edition, but you could also use OpenSite or OpenRail Designer. I'm using the Training and Examples workspace and the Training Imperial Works set, but you will probably have your own DOT workspace that you'll select, and that will provide all of the feature definitions that we'll be using in a moment. So I'm going to create a new file. I'll give it a name and check the location, check that my seed file's correct. It's a 2D seed file and click Save. Once the DGN's been created, I can select the Drainage and Utilities workflow and then go to the Tools ribbon and click Model Builder. Confirm that I want to create a utility model in the design file, and then we can begin the process of mapping our Excel data. The first thing that we need to do is select the data type for this command, for Model Builder. We can choose between hydraulic analysis and subsurface utilities. We're importing drainage data, so we may want to do hydraulic analysis on it. So we'll select the hydraulic analysis data type and click OK. So we're going to use Model Builder to map the data from our Excel spreadsheets into drainage and utility properties. So we'll start by creating a new connection, and then we'll choose the data type, which in this case is the latest version of Excel, but as you can see from the list, there's many data types that you can use in Model Builder. Then we'll select our nodes and areas spreadsheet and click Open. We've read the spreadsheet and we found that there are two sheets in there which we refer to as tables in Model Builder. Ultimately, each table will map to an individual feature definition. So for the nodes table, we need to map this data to multiple feature definitions. Now the node type column shows that we have curb, junction and outlet types of node, and for the junction we have box and circular shapes. So we need to break down this table into multiple feature definitions. We can do this using a where clause. So I'm going to turn on where. Now because the node type column contains embedded spaces, I'm going to start with a square bracket. I'm going to type node type square bracket, and I'm going to say equals, and then I'm going to type single quote curb. Now the single quote can also be used to handle embedded spaces. I'm just using it here out of habit, and if I click the green arrow icon, the list is filtered down into only those node types of curb. I need to now create several other where clauses, so I'm going to select the table and I'm going to duplicate it, and I'm going to change the node type from curb to outlet. Press the go button, and that's our second where clause created. We'll do the same again. I'm going to turn off the where clause and press the green arrow icon, and this time round I want to filter on a node type equals junction, but I also want to filter on the shape, box or circular manhole. So that's node library item description. So we'll turn on the where clause again, and we'll filter on the node type equals junction, and then we'll do and open bracket again, node library item description, close bracket, equals box. Click the green icon, and then we filtered that list down to the one box junction. We'll duplicate the table again, and instead of equals box, we need to pick up the circular chambers. So I could, instead of an equals, use like single quote circular, and then I can use a percent symbol to catch any succeeding or trailing characters. Single quote again, press the green arrow, and there's our final where clause, and we've now caught all of those different feature definitions from the nodes table. Don't need to use a where clause on the areas, so we can click next to go to the next stage of the wizard. The coordinate units are feet. I'm going to uncheck create nodes if none found at pipe endpoints, because I'm expecting there to be nodes at the ends of every pipe, and if there's one missing, I'll get an error message, which means that I can go back and check my data. The default settings in this step are fine, so I'll click next. Again, these defaults are fine, so I'll click next. And here's where we actually map the columns of data from the Excel spreadsheets into our hydraulic properties. So the areas table represents catchments. So I'll click element types, catchment. The key field we're going to use is the area ID. We need an X and Y coordinate for our areas, and this is why I pasted in the data from the nodes CSV file, so I can select that here. Now that's the mandatory mappings at the top of the screen, but we've also got some other values here that we want to map. So the time of concentration maps to a hydraulic property called time of concentration. The composite C value maps to runoff coefficient rational. Actually, let's just go back to this time of concentration. Notice the default units were hours. Now in the GEOPAK data, and therefore the spreadsheet that we created, the units were minutes. So we need to select the correct units. You need to get that right at this stage. The C value is unitless, so that's okay. The next column from the Excel data is the area composite area. We'll map that to area user defined because the Excel data defines the area. Node location X and Y we've already done. We need to define the discharge from this outfall. We need to define the discharge for the catchment area, and that is the outflow element label. And then finally, use scaled area, which is that column that we manually added to the areas Excel sheet. That maps to use scaled area because we don't want to use the area of the catchment polygon. We want to use the area that we're importing here. So now we go to the first of the nodes tables. Let's just widen this out so we can see which one it is. So this is for the curb. So we'll go to element types, catch basin. We'll fill in the key fields again. So let's do the node elevation. That will map to elevation ground. Units of feet. Node minimum invert elevation will map to elevation invert. I'm also going to map the node library item name, and I'll just go to the preview tab and turn on show preview to the notes field so that I have a record of the library item that was used. We'll look at how to map the reference chain and tin in a minute. So that is these mappings set up for this table. So I'm going to click the copy mappings and I'm going to paste them onto the next row. Then for the next table. Now this is for the outlet, so I need to change the element type to outfall, but the other field mappings are all okay, so they can stay as they are. We'll select the next table and paste the mappings in again. This time round, instead of a catch basin, it's a manhole. Then we'll copy those mappings and paste them onto the final table. So the mappings for the two junction tables are the same, but we can now set separate feature definitions. We'll look at specifying the rotation in a minute. So we'll now click Next. And here's where we specify the feature definitions, one per table. Now you'll be selecting feature definitions from your DOT workspace, but I'm just going to set some reasonable feature definitions now. So I've chosen a feature definition for my areas, one for my curb inlets, one for my outlet, and I've chosen two different feature definitions for the two junction tables, one representing a square chamber and one representing a circular chamber. So I can click Next. I don't need to use snapshots. I'll click next. Would I like to build the model now? I'm going to say no, and I'm going to click finish, because that mapping table is now saved. Once that mapping table is saved, it can be used repeatedly, and I'm going to just highlight it and then click Sync into Model, confirm the message box, and that will build our model of the nodes and the areas. The summary panel tells us what we've got. There are no messages, which means the mappings are all working correctly. We can then close the summary panel, close the model builder panel, synchronize the drawing, and that will update the design file with the elements from the database, and we can fit the view to see them. One thing that we're not currently able to map is the rotation of the nodes, but there is another way to set that. So I'm going to go to the Utilities View ribbon and Flex Tables, and on the Subsurface Utilities tab, I'm going to double-click Stormwater Nodes. Now I need to add the property for the rotation, so I'll click the edit icon, scroll down to see the rotation property and double click it to add it to the list of selected columns. Then click OK, and then we see the extra column added. Now going back to our nodes and areas spreadsheet, I'll scroll across to the right, and here's the data for the node rotation. So I'm just going to highlight those cells, do a Control C, and then I'm going to click in the first cell and do a Control V to paste that data in. And then we can close the flex table. The next stage is to map the conduits. So we'll go back to Model Builder. Again, we'll choose the hydraulic analysis data type. We'll create a new connection. Select the latest format of Excel again, and we'll browse to our links spreadsheet. We can show preview to see what's in there. So we'll click next, 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 and here's where we do the mapping. So the table type is conduit. The key field will use link ID. The start is the node at the start end of the conduit, which is link upstream node, and then the stop will be link downstream node. So next we'll map the link invert upstream, which maps to invert start, the units of feet, and we'll do the downstream invert. Then we're going to map set invert to start, and this is one of the columns that we manually added into the spreadsheet. And what we're doing by setting these to false is we're saying we want to use the inverts on the link. If we don't map these fields, then the software will assume, or Model Builder will assume, that the inverts of the conduits need to match the inverts of the nodes, and that may not be the case. So all of our conduits in this case are circular, and Model Builder will assume a circular shape by default, so we can map the link rise data from the spreadsheet to the diameter field. Let's just check the units. Link rise, that's in feet, so we need to set the units to feet. We'll go back to the preview one more time. The link library item might be worth retaining, so we'll find that and we'll map that to the notes field. Then we'll click next, and we'll map the feature definition. We'll map it to a concrete pipe. I don't need to set a feature definition for missing nodes because we've already imported the nodes. So we'll next through here. Would I like to build the model? I'll say no and click finish, because that saves the mapping table. Then having selected that table, we can click sync into model. OK the message box. The data's been read, there's no messages, so we can close the summary, close the model builder dialog, and click yes to synchronize the database with the design file. If we zoom in now, we can see the differences in the feature definitions. There's our circular manhole, for example, and there's our curb inlet. We can see how the conduits have been clipped to the edges of the curb inlet node, and that's because the connection regions are all around the 4 internal faces of the node. So that's worth considering, because if the conduits intersect the connection regions, they will be automatically clipped, as you see here. The hydraulic properties of the inlets will come from the feature definition that we associated in Model Builder, so they would normally be set up to use an inlet catalog with the correct hydraulic parameters such as curb length and so on. If we select a catchment area, we can see the hydraulic properties for it. We can see the runoff coefficient, the user-defined area, and so on. Finally, now that we've set up these model builder mappings, we can use them repeatedly on different Excel spreadsheets. Just by double-clicking the connection, we can go and select a different data source and import that data. We can also export these connections out to an external file, which can be shared with other users. If the nodes in GEOPAK drainage used a terrain to derive their ground elevations, then we can do the same thing here. I've created a terrain having exported the tin from GEOPAK site. So I'm just going to turn on the reference for that. I've also imported the GEOPAK chain using the import geometry tools. So then I can go to a flex table of my nodes. I can do select in drawing, and that creates a selection set of all of the nodes. Then I can come to my properties, and then I can use the elevation reference property, click the browse button, and pick the reference element, so in this case the terrain model, and that will now associate that terrain model to all of the nodes. So if we just zoom in and pick one of those nodes, we can see that the elevation reference has been set, and what was a specified ground elevation is now a vertical offset from it. If I turn off the terrain model, and we create the selection set again, we can also set the station offset reference again, browse, and select the chain to set the station offset reference. And then if we look at the hydraulic properties of the node, we see the baseline feature and the station and offset set there.
The second option we have to import our drainage is using an OpenFlows product.
This is the GEOPAK drainage data that I want to import into a Connect Edition product. Here I'm running GEOPAK Suite on MicroStation Select Series 10. So I see a subsurface utility menu. But in this workflow, we're going to look at how to import this data from GEOPAK Select Series 2. In Select Series 2, the subsurface utility menu will not be available, so we need another workflow to import the data. Now, I've installed an OpenFlows product. In this case, it's StormCAD, but it could be SewerCAD, SewerGems, or Civil Storm. And that installation will integrate with the V8i products and give you a menu that you can select. When you install the OpenFlows product, it will integrate with GEOPAK Suite and Power GEOPAK as well, so this workflow can be used in both versions of GEOPAK. The first thing I need to do is create a new OpenFlows project, in this case a StormCAD project, so I'll go to File, Attach New. I need to type a name for the project, so I'll call this one Site 1 Drainage. Choose a location for the project to be saved in and click Save. Don't need to enable change tracking, so I'll OK that menu. And now I can go to StormCAD, File, Import, GEOPAK Drainage. I can select the GEOPAK Drainage file and click Open. The data is read. I'm asked if I want to synchronize the drawing and the database. I need to click Yes to that. I can then review these user notifications if I want to and close that panel. We can at this point review that data if we wish. So if I zoom in here and I use the StormCAD View Properties menu, I can select, for example, a conduit, and I can see the properties in the StormCAD database. I now need to create a selection set for the elements that I want to export to a submodel. So I'm just going to use a crossing window, and I'm going to go to StormCAD, File, Export, Submodel. I'll type a name for the submodel file and click Save. That process is now completed, as the message says. I need to supplement the submodel that we've just exported with a little bit more information from GEOPAK Drainage. Now, I'm running GEOPAK Suite, so I'll go to the Applications GEOPAK Drainage menu, and I'll open the GEOPAK Drainage project. Then I can go to the Reports menu and Report Builder. I want to create a report for the nodes component, so I'm going to select that. I'm going to select the library item name and the node rotation, include those. I'm going to change my file extension and number of decimal places and click Generate and View. And then I'll save that file as nodes.csv. Now I can close these dialogues and close GEOPAK Drainage. The next step is to import that exported data into the Connect Edition product. I'm running OpenRoads Designer, but you could do the same workflow in OpenSite or OpenRail Designer. I'm using the Training and Examples workspace and the Training Imperial workset, but you will probably have your own DOT workspace to select, which will already have the required feature definitions that we'll be using in a moment. So let's create a new design file. We'll give it a name, check that our seed file's correct, and click Save. The next step is to create a drainage and utilities project in the design file. So I'm going to select the drainage and utilities workflow and go to Tools and click Project Defaults and confirm the message. And then I can OK the options panel. So that process has copied settings from my Drainage and Utilities DGN library into this design file. So for example, if I go to Analysis and Scenarios, you'll see that there's 2 default scenarios created. It's also set up things like prototypes, as we can see here. Having created the Utilities project, I can now go to the Home ribbon, and under Import Utilities, I can import OpenFlows submodel. OK the message box, then I can select the submodel that we exported earlier and click Open. and the data is read into this design file. Once that process is complete, we can fit the view to see the data. So if I go to my references, I can turn off the display of the 3D model reference. And then if I zoom in and select, for example, one of the nodes here, we can see that it's got default symbology and there is no feature definition applied. Same applies to our conduits and our catchment areas and so on. The data's here, but we need to improve the symbology. I've opened the CSV file that we created in GEOPAK Drainage Report Builder a moment ago, and I need to do a find and replace. I need to replace this single quote character, so I'll do a Control F and say that I want to replace that with FT for feet. And that data is now ready for me to use. So I'll go back to the Connect Edition product. I'll just move this up the screen so that you can see the status bar. And I'm going to go to the Utilities View ribbon and Flex Tables. Now note the two tabs here, one for subsurface utilities and one for hydraulic analysis. I need to be on the subsurface utilities tab, and I'm going to double click the stormwater nodes icon. I'm going to click the edit button because I want to add the property for rotation into my list. So I double click it on the left hand side, or I can single click and click add to add it to the selected columns. Now I can go back to my Excel spreadsheet. I'm going to select those cells for the rotation, Control C to copy, and then I'm going to click in the first cell there and do a Control V. I'm then going to go back to the Excel file and I'm going to select the library item name cells, and again Control C there, and I'm going to paste them into the notes column. I just need to tab across and Control V, and we'll expand that notes column. I now want to use a filter on the notes column, so I'll just move the flex table across to the left. I'm going to right click on the notes column and say filter custom. Because I right clicked on the notes column, it's highlighted in the available field, so I'm going to double click that, then I'm going to click equals, and then I'm going to refresh the list of unique values. So let's say we want to build a selection set of all the 4 feet diameter manholes. I'll double click that item. That goes into the query builder at the bottom of the dialog. And this is why I replaced the single quote with the characters FT, because the name of the unique value is enclosed in single quotes. If I click the apply button, that returns 2 out of the 14 elements, so I'll OK that and I'll OK the query builder. So now the flex table has been filtered so it only contains 2 of the 14 elements, which we can see in the bottom left hand corner there. If I now select the select in drawing icon, that's now built a selection set of the 2 elements, and now I can browse the feature definition. So here's where using the correct workspace will come into play. So I'm using the training and examples Imperial workspace. So the feature definitions that I have available to me here will be those from that workspace. So I'm going to use a manhole feature definition, so I'll select that and it is applied to our selection set, in this case the 2 nodes. If I now zoom in on those nodes and zoom in closely, you can see how the conduits have been clipped to the edges of the node. Now in this particular case, I've selected a node which is circular and its connection region is also circular. And what's happened is that if the conduits intersect a connection region, they will be clipped to it. You can use the manipulator if you want to reconnect the conduit, but if you've got nodes which are represented as a rectangle and the connection regions are just shapes on the sides of the node, you might want to have a think about maybe increasing the size of the connection regions just to make sure that the conduits are clipped to them. So we can also go to View Attributes and turn off the construction class graphics if we want to. We can then go back to our flex tables. I'll go back to Stormwater Nodes and I can right click on any column and reset the filter to get back to the previous list. Then I could continue with my filters and set my feature definitions like that. And you can see here that these two nodes have that manhole feature definition selected. Similarly, I could go to the flex table for the stormwater conduits, use filters as appropriate, and then create a selection set to apply the feature definition. In the case of conduits, it might be useful to bring across the GEOPAK drainage information for the material, which, as you've seen, I can paste into the notes column, so I could filter, for example, on a circular shape and a concrete material, and then create the selection set and apply the feature definitions to those. If the nodes in GEOPAK drainage used a terrain to derive their ground elevations, then we can do the same thing here. I've created a terrain having exported the tin from GEOPAK site. So I'm just going to turn on the reference for that. I've also imported the GEOPAK chain using the import geometry tools. So then I can go to a flex table of my nodes. I can do select in drawing, and that creates a selection set of all of the nodes. Then I can come to my properties, and then I can use the elevation reference property, click the browse button and pick the reference element, so in this case the terrain model, and that will now associate that terrain model to all of the nodes. So if we just zoom in and pick one of those nodes, we can see that the elevation reference has been set, and what was a specified ground elevation is now a vertical offset from it. If I turn off the terrain model and we create the selection set again, we can also set the station offset reference. Again, browse and select the chain to set the station offset reference. And then if we look at the hydraulic properties of the node, we see the baseline feature and the station and offset set there.
The final step in our project migration process is to validate the information that we've brought in. To do this, we'll use the reports that we created in our previous version. Finally, this presentation is meant to be used as a guide. There may very well be questions you have that are not covered in the presentation. If so, please log a support ticket and we'll be glad to help you with any issues you may encounter.